So hello everyone, it's me Sanket Motivar and I am going to present on the storage and querying point, which is the storage and file structures. So moving ahead, so first of all, introduction to storage and querying. There are three main steps in the storage and querying, which is first is the data retrieval, which is handling efficient handling about the retrieval of the data. Like if we are taking the examples of any Word document or any Drive document that we retrieve after we when we want, like if we upload uh, any PDF on the Google Drive, then for retrieving purpose we can use that also. Then there is a data backup. So as in the example of the WhatsApp or any other social media, there is the option of the backup of the data. So we can also take the backup of the data, which is stored in the some hardware database of that company. Then there is the next is the optimized performance. So we can also optimize the performances by increasing the speed time, by increasing the processing time, by making it efficient and decreasing the processing time. We can make it more efficient by optimizing the performance. Then the next is the overview of physical storage system. So there are two types. One is the data backup and the performance optimization. So in the data backup, utilizing the secondary storage like magnetic disk ensure reliable data backup solution, safeguarding against data loss while providing necessary access for database operation during the recovery process also. Then there is a performance optimization also, like we can optimize the performance by improving the time required for the processing and also to decreasing the time required for making it to appear of to us. Then the next is the types of data storage explained. So there are three types mainly. First one is the primary storage, second one is the secondary storage, and the third one is the tertiary storage. So the primary storage utilizes high-speed memory directly accessible by CPU for quick data retrieval and processing purpose. The next is the secondary storage, which employs hard drives and SSD for long-term data storage, balancing the cost and the performance also. Then the next is the tertiary storage, which usually stores media like the tapes and optical discs for archival purposes and backup solutions. Then moving ahead to the characteristics of storage media. So there are four types of memory storage like flash memory, magnetic disk, optical storage, and tape storage. And for each, there are characteristics like type, speed, cost, durability, usage. So for flash memory, the type is EEPROM, speed is the fast, cost is the high, durability is the moderate, usage is the small data storage. And for like magnetic disk, type is the disk based, speed is the moderate, cost is the low, durability is high, usage is the long-term storage. Next, for the optical storage, the type is the laser read, the speed is the slow, cost is the moderate, durability is moderate, and the usage is data distribution. Next is the tape storage, type is the sequential access, speed is the slow, cost is low, durability is very high, and usage is also better. Then moving ahead to the DBMS file structures introduction. So there are total four types: file access, data organization, index utilization, storage optimization. So first of all, file access, that is the efficient retrieval of records, improves application performance and reduces the search time in database systems. Next is the data organization. Structured file organization methods minimize the data retrieval cost and enhances the overall database efficiency. Then the next is the index utilization. Effective indexing methods enable quick access to the data and significantly reducing query execution time. Then the next is the storage optimization. The optimizing file structures leads to better resource management and improved performance of storage media. Moving ahead with the file organization methods. For organizing the files, there are many methods like B plus trees, hash file organization, and many others, which based on the access patterns to enhance data retrieval efficiency by ensuring the faster query performance and optimal resource utilization for improved application responsiveness in database systems. So moving ahead, understanding the indexing mechanism. So first one is the B tree usage, utilizing the B trees for efficient searching and sorting within the large data sets, providing balanced tree structures that enhances the query speed and minimize the disk access time. So it will be benefited for us too. And then next is the bitmap indexing. So in this, they implement bitmap indexing for categorical type of data, which allows the rapid querying of large data sets by reducing the need of extensive disk scans and speeding up retrieval data significantly. So moving ahead with the query processing steps overview. So first one is the parsing, that is the analyzing the query for accuracy and structure. The next is the translation, that is the converting the query to a format the DBMS understands. The next is the optimization, that is evaluation of the execution plans for efficiency and cost. The next is the plan selection, which chooses the best execution plan from options. The next is the execution, that is implementing the selected plan on the data. The next is the text here, that is the fetches data based on the execution results. The next step is the return results, delivers final data to the user or the application. And the next is, which is the final, that is the cleanup, that is releasing the resources that we have used during the query processing. So moving ahead, types of indexing structures. So there are like six types: B-trace, bitmap indexing, single indexing, multi-level indexing, primary indexing, and the secondary indexing. So B-trace is commonly used for balancing indexing in databases. Bitmap indexes is the second one for effective indexing low cardinality data efficiently. Next is the simple indexing, that is the single indexing, simplifying the queries by mapping unique keys to the records. Next is the multi-level indexing, which enhances the search speed using hierarchical storage methods. Next is the primary indexing, direct access based on the primary key for fast retrieval and accessing also. Then next is the secondary indexing, which creates the additional pathway for storing of the data. So moving ahead with the query optimization techniques, there are many techniques like rewriting the queries, using the indexes, analyzing execution plans, limiting the result set, joining the optimization, considering the caches, and also the batch updating. These are the techniques used for the query optimization. So moving ahead with the execution plans and engines. So first one is the parsing, that is the analyzing the query for lexical and semantic correctness. Second one is the optimization, evaluating the potential execution strategies to minimize the resource consumption. Third one is the execution plan, directs how the DBMS will access and provide the data. Fourth one is the execution engine, which carries out the plan to retrieve and return query results also. Moving ahead with the summary of the storage and querying concept. So the types of storages are like data storage is categorized into the types like primary, secondary, and the tertiary type. And then next is the importance of indexing. That is, indexing optimizes the performance by enabling faster data retrieval processes. Next is the query processing stages. Query processing involves parsing, optimization, and execution stages of efficiency. Next is the file organization methods. Various file organization methods impact database access speed and efficiency also. Then there is a RAID technology. RAID combines multiple disks to improve performance and ensure data redundancy. Next is the optimizing the queries. For optimizing the queries and minimizing the resource usage, and enhancing overall query process performance is the main motto of optimizing the queries. So thank you.